Hi, welcome back to MacroLearning. So draw the structure of the alkane. So we're still in the alkanes part. The alkane whose formula weight is 72 grams per mole and whose chlorination produces one of these. Okay, so only one monochlorination product, or 3 or 4 monochlorination products, or dichlorinate, 2 dichlorination products. So we have to draw the structure one structure that meets each one of these conditions. And in the meantime, the formula weight is 72. So first let's figure out what the alkane is at that formula weight. We know for alkanes it's let's change colors real quick. Okay, alkanes are like CnH 2n plus 2. Okay, and 72, so n times 12, that's the atomic weight for carbon, right, plus 2n plus 2 times 1, that's the hydrogen's atomic weight, and that's 72. So from there it's 14n equals 72 minus 2 is 70, so n equals 5. So it's going to be a C5H12. It's a 5 carbon alkane, which is a pentane. And to figure these out, figure out the structure that meets each one of these, I think the best way to do it is to first try to draw out all the isomers, all the possible isomers based on this formula. So the most straightforward one would be a straight chain pentane, right? And from there, like I showed you before, the systematic way is to chop one carbon down, or chop one carbon off, excuse me, and use that carbon as a substituent onto the shortened main chain. And there you go, that's methyl that comes from the carbon that got off from the original chain. And also that's going to be the only possibility for 4 carbon main chain isomers. And if we go one more carbon down, remove 2 carbons from there and end up with a 3 carbon main chain. So what we can do with the 2 carbons is to have them as 2 methyl groups on the middle carbon, both of them. And that's also it for 3 carbon main chain structures. Now what about this? The 2 carbons off existing in one single ethyl group. Now, like I showed you before in another video, this is not going to be a new structure. It's not a new structure because here you're changing the length of the main chain now. It's a 4 carbon main chain once you add the ethyl group to the 3 carbon initial original main chain. So you're changing the main chain, so that's where you stop and disregard this structure as a new structure, because it's gonna be a duplicate of either one of those that you have already, all right? Duplicate with one of those that you have already, or it's gonna duplicate with something you come up with later. And so that's not a new isomer. So these are the only possible isomers for CnH12. And let's go ahead and draw out the full structure so that we can see the hydrogen atoms clearly. So this one is right, and this one is CH3, CH2, CH, CH3, there's methyl here. This one is 4 methyl groups all connected to the same central carbon. Okay, so when it comes to monochlorination, it comes down to the question of how many different hydrogen atoms you have, how many different types of hydrogen you have in each structure. For this one is going to be, let's label the hydrogens. This is type 1 hydrogen. This is also type 1. I'm calling it 1 to, just starting with the ones on the sides or on the ends. But these 6 hydrogens are all same, and these 4 are all same, and they belong to a single type. Let's call it type 2, and these 2 in the middle is another type. So we have 3 types of different hydrogen atoms, and that means we have 3 monochlorination products. 3 monochlorination, I'll put it this way. And this one, okay, we got these 6 methyl groups. I'm sorry, these 6 hydrogens being the same, all belong to, oh, sorry, I wasn't really doing what I wanted. These all belong to the same type of hydrogen. Call it type 1, and I'll call this type 2. Okay, this is still a methyl group, but it's different than these 2 methyl groups because of the way the structure is, right? So these 3 hydrogens are different from these 6. So it's type 2, and this 2 hydrogens belong to yet another type. It's type 3, and this one is type 4. Okay, so 4 different hydrogen atoms, and that means 4 monochlorination products. 4 monochlorination products. And this one is an interesting one because all 12 hydrogens are the same. They all belong to one single family, right? All 12 of them. So there could be only one monochlorination product. Only one mono. So now we know what the structures are for the first 3 parts of the question, right? So for number 1, okay, let's call this structure 1, structure 2, structure 3. So the one that meets number 1 is going to be number 3, right? And the one that satisfies number 2 condition is 3 monochlorinated products. Number 1 and number 2 is the one. Number 2 is the one that satisfies condition number 3. All right. Okay. So when it comes to number 4 condition, 2 dichlorination products. Okay. Let's think about dichlorination. Let's redraw the structures real quick. So how many dichlorination products are possible from, let's draw all of them. How many dichlorination products are possible for this isomer? There could be, right? And another one could be like that, okay? And so it's going to be way more than 2. Way more than 2. Many more than that, actually. And beyond those, I just had, there could be structures where you have 2 chlorines of the same carbon, and that gives you at least 3 more isomers. So this structure is not the answer for part 4 condition because there are going to be way more than 2 dichlorination products. Okay. It's not the best way. How about that? Okay, way more than that. And how about this one? So it could be this or this, or this. So it's already more than 2. And if we count the ones where the 2 chlorines can end up on 1 carbon, it's going to be many more than 2 again. So it's not the answer either. So this is going to be the answer because there are only 2 possible dichlorination products. Let's see. So if the 2 chlorines are on the same carbon, because this carbon we cannot get a chlorine onto it because it's there's no hydrogen connected to this carbon. It's got no hydrogen. So the only dichlorination products where both chlorine are on the same carbon atom is this. I mean, you can put them on this carbon, and this carbon, but it doesn't make it a different structure because all these carbons, all these hydrogens too, are equivalent. So, and if we put the 2 chlorines on different carbon atoms, we could have this, or this, but it's still the same structure. This still the same as this because of the way it's structured. All the carbons on the end except for this are same. So this is the only dichlorination product possible where you put 1 chlorine on each carbon. So overall there are only 2 dichlorination products. Let's see, let's draw the other one out just in case. Right, so that's it. Only 2 possible dichlorination products. So that's the answer for number 4. So structure number 3 meets the condition described in number 4. That's it. Okay, so this is it for that question, and thank you so much for watching. I'll catch you later.